everyone, welcome back to Cirrus Talk. I'm Grant Nunez.
I'm Ava D. Board.
And I'm Caroline Crater. Tonight we have a Cirrus special report on severe weather.
Right you are, Caroline. In 2017, NOAA reported a total of 38 deaths in the United States, all associated with severe weather outbreaks linked to tornadoes.
Tornadoes have detrimental effects on the community struck, causing millions of dollars in damage and loss of lives.
But what can you do to help prevent the loss of your life and the ones around you?
Well, experts in severe weather have worked for years to maximize warning times to those in the path of severe storms.
Those times have drastically increased with new technology. In times of dangerous weather, even the fewest seconds can determine whether you are safe or just another statistic.
Luckily, we have our own experts here at Cirrus Talk, our chief meteorologists, Logan Clethermis and James Green. Logan has been a storm chaser since he was in his teens. His mother was a chief meteorologist, analyst, and storm chaser for the National Weather Service in the Midwest.
James specifically studied severe weather during his tenure at the University of Missouri, where he developed warning systems to help increase warning times for those in the path of severe weather.
Welcome, Logan and James. Now tell us, how can we spot a storm and what to worry about?
So the first ingredient that you need for starting a thunderstorm is you're going to need the sun's rays. So through insolation, it heats the air on the ground, the surrounding air here, creates a warm bubble of air. This air rises because hot air rises, and then it slowly starts to cool and condense, and this is where you get these clouds and possible thunderstorms as well.
Now this is a really good example of a cumulus cloud. Now what makes a cumulus cloud so special is that as the water particles come up, it condenses and forms like a normal cloud, but then warm drafts come up through the atmosphere caused by a low pressure system, and that will cause your cotton ball tops here, and then it will create a flat basin right here.
So this is a typical example of a cumulonimbus cloud. So the first thing I'm going to talk about is kind of how the air moves with inside the actual thunderstorm. So first, of course, as Logan had mentioned earlier, you have water condensing in the cloud. So that creates these cold air movement that's being forced down, and that's where you're getting your precipitation here as well. So because of that force and the pressure that it exerts, it's pushing this warm, moist air up. So then this warm, moist air is going up here, it's condensing, and it's coming back right back down.
Now this is an example of a supercell, which has the cumulonimbus, the shelf cloud, and you can see right here the wall cloud, all in the same system. Now, kind of like James was saying before, you have cool air sweeping down to kind of like the basin here, and then as it's coming down, it's pushing up warm air like so, which is kind of like feeding in to the whole like supercell system. And as this happens, it draws up warm, moist air and creates the shelf cloud, as seen right here. Now, the shelf cloud isn't dangerous itself, but it's kind of like a sign for bad weather to come. So what you really want to look for is the wall cloud, which is formed right here. Now, this is a rotating cloud that forms underneath the cumulonimbus cloud. And when you start to see it spin counterclockwise, that is generally a good sign for a tornado that is approaching.
Okay, so this is a typical real-life representation of what a cumulonimbus cloud would look like. As you can see, you have your anvil here, and then of course you have your precipitation here, as well as your shelf cloud.
And as you can see here, you have a wall cloud, which always forms behind your precipitation. And then in this example, we have a tornado that is coming out of the wall cloud.
And now we're actually going to go to Logan, who is going to go out in the field for us.
Well, thank you, James. As you can see, this is a great example of a thunderstorm in our area. There is definitely a large rain droplets falling, and they're falling very hard, as you can see behind me. Thank you for tuning in to this special report. Now back to the studio.
Well, thanks so much, Logan, for that great action shot of what you can find in your neck of the woods.
Yeah, that was quite eventful. Logan sure does love to chase storms.
And that goes to show you, folks, clouds are much more than just fluffy-looking cotton balls in the sky.
And that's some Cirrus talk.
Don't you mean cumulonimbus talk? No, in all seriousness, I hope everyone enjoyed this serious special report.
Make sure to tune in next time on
Cirrus Talk!